Hey, eighth graders. Yesterday we explored and discovered what a function is, or maybe we explored it and discovered it. Today, your long wait is over. You get to finally know what the official definition of function is. What is a function? Please get out page 62, and on the top of page 62 it says define function. I'm going to show you that definition and you can write it down. So here it is. What is a function? It is a relationship where every input has exactly one output. And we're going to make sure today that we very thoroughly understand that definition. Another way you'll hear it said, because often we connect things in a mathematical relationship with the variables x and y. So you can also think of it as the relationship where every x has exactly one y. Okay, now what does this mean, input and output? Well, we sometimes visualize it as a function machine, and this is not really an official mathematical definition. It's just kind of a visual that you can use to help you see what's going on. A function machine is this idea of the input goes into the function machine, some kind of rule is applied to it, and based on that rule, you determine what output you get. So the function machine is whatever that rule is that determines how the input becomes the output. And oftentimes they're mathematical rules, like the output is twice the input, or the output is 1/2 of the input plus 4, or something like that. So it's this rule that determines how that input becomes the output. And if you can follow some kind of rule, usually that input will lead to only one specific output. If you have an input that can lead to multiple outputs, then you don't have a function. And let's work through some examples and make sure we're really clear on this. So it says here, for each situation below, fill in the missing information in the tables. Then answer the questions that follow the table. So here's a scenario right up here. A parking meter takes only dimes. So you go to this weird place and you park there, and there's a parking meter. If you've ever been downtown, you've used one. But this particular parking meter only takes dimes, and each dime that you put into the parking meter gives you 6 minutes of parking time. So each dime is worth 6 minutes. With that information, can you please fill in this table? Take a second to do that. Fill in that table. Did you do it? I bet you were able to figure it out, right? If you put in 2 dimes, how many minutes of parking did that give you? 12 minutes of parking. 3 dimes was 18 minutes of parking, and 7 dimes was 42 minutes of parking. Is there some kind of rule that you guys were following to fill in this table? What was the rule? And when we say rule, it could also be patterns. It could be just what is it that you were doing over and over again to determine how your number of dimes turned into minutes. Well, weren't you guys taking the number of dimes? Minutes were equal to the number of dimes times 6, right? That's a mathematical rule that you guys were following. And what was happening is, let's define this in terms of the function so that we can connect this definition in our brains. So what was the input in this scenario? The input was number of dimes. And it's handy that in this particular scenario, you are literally inputting a dime into a parking meter. That doesn't have to happen for you to define it that way. But the input was the number of dimes. The output was the minutes of parking. And here's the million-dollar question here that you're going to be asked a lot in the next little while. Is this relationship a function? How do you know? Well, let's go back to our definition. Our definition says a relationship where every input has exactly one output. So here's what this question is really asking you. Does every number of dimes have exactly one value for the number of minutes? For example, specifically when I input 2 dimes, is this the output I'm always going to get? If I input 2 dimes, do I get 12 minutes of parking, or do I sometimes input 2 dimes and I get 40 minutes of parking? Is it like you go up to this parking meter and you just put your dimes in and you never know what you're gonna get? No, that would really make people mad if that's how it worked, right? When you input 2 dimes, you get 12 minutes of parking. When you input 3 dimes, you get 18 minutes of parking. When you input 7 dimes, you get 42 minutes of parking. You're never going to input 7 dimes and get some other output because, yes, we're going to word it like this. You ready? Because every number of dimes, 2, 3, 7, 12, which I'm going to put in parentheses, is the input. You want to be nice and specific. Don't just spew the definition back. Prove in your explanation that you get what that definition means. Every number of dimes, or every input, has exactly one amount of minutes. For the output. That's what matters when it comes to a function. If I put in 2 dimes, do I know exactly what I'm getting? Because if it's a scenario where you put in 2 dimes and you have no idea what the output's going to be because there's a whole bunch of them, that's a scenario where it's not a function. But in this case, when I put in the number of dimes, and the fact that there is a rule that's happening here, when I put in 2 dimes, I multiply it by 6 and I get my minutes. That means every input has exactly one and only one output. You can think of this as when you do the input, do you know what the output's going to be? Because if you do know what the output's going to be, then yes, you're dealing with a function. If you have no idea what the output's going to be, or if there's more than one option for the output, then no, it's not a function. Let's try this again and make sure. What if we flip this around? What if I change it here so that the input is the minutes of parking? What if I just switch it? The input is the minutes of parking, and now the output is the number of dimes. Okay, so I'm switching that. First things first, can you take a minute right now and finish the table? If I give you minutes of parking, can you tell me the number of dimes? 0 minutes of parking means you use 0 dimes, right? What if you got 12 minutes of parking? How many dimes did you use? You must have used 2. What if you used 54? I mean, you got 54 minutes of parking. How many dimes did that take? Let's think about for a second, is there a rule that can be followed here? In this case, you are now finding the dimes by doing minutes divided by 6, right? We're doing an inverse operation because we're going backwards. So 54 divided by 6, that must have taken 9 dimes. Now, here's the question. Is this relationship still a function? So I'm going to tell you, sometimes when you swap around the input and the output, sometimes it still works, it fits the definition. Sometimes it doesn't. So let's see if this one did. If our input is now minutes of parking and our output is number of dimes, the question is still back to the definition. Does every input have exactly one output? And the answer is yes, because every time amount, I'm just going to put that, every amount of time probably would have made more grammatical sense, but in this case it was the input, has exactly one number of dimes. You still know what you're going to get. And this would be a scenario like you're standing in front of it and you're like, I know I need to park here for 54 minutes. How many dimes do I need? You know the answer to that. You know I need 9 dimes. That means your input of 54 minutes has exactly one output of 9 dimes. So every time amount or input has exactly one number of dimes or output. So in this scenario, when we switched them around, that every input has one output, that was still true. Be careful though, sometimes when you switch them, it's no longer true, and you'll get plenty of practice on that as we go forward. Let's keep going. It says, use the graphs given to fill in the tables and answer the questions. Okay, here's a graph. Let's read our labels. Down here it says shots attempted, how many you tried, and then it gave me a table here. Over here it says shots made, how many actually went in. Okay, the way they've set up the table here, what is the input? The input is shots attempted. how many you tried, and the output is shots made. Well, can we fill in a table for this? Let's look at our graph. If you attempted 2 shots, follow this up. How many shots did you make? Well, 0. What if you attempted 4 shots? How many shots did you make? Uh-oh, I have 2 dots here. Do you remember how we talked about the vertical line test? This particular scenario fails the vertical line test, and here's how this connects to our definition. If I know the shots attempted were 4, then the shots made could either be 1 or 3. And that's a problem because it means this input is not leading to one direct output. It means if I say I attempted 4 shots, you're like, well, did you make 1 or did you make 3? We don't know because there's more than one output that belongs with that input. That particular input has 2 different outputs. That's not a function. This input of 5 also has 2. It was either 2 or 4. What that means is my input is not leading directly to one output. So is it a function? No. Why? Because some inputs, I'm going to label it this way, which in this case were attempted shots. And I'm just going to word it like this, have multiple outputs, which is the shots made. Make sure your description doesn't just regurgitate the definition. Make sure you prove to me that you know what the definition means by applying input and output to your scenario. So in this scenario, no, because these inputs have more than one output, so it is not a function. Okay, again here, down in this last one, we have miles jogged, so the input is miles jogged. The output is day of the week. And the question is, of course, is it a function? Let's fill in our table and see what we see. This is a bar graph which throws people sometimes. And they switch things around on us. So miles jogged, do you see the miles jogged is 2? If I go across like this, there's only one day of the week that happened, and that was on Wednesday. Okay. Miles jogged was 3. Ooh, that happened on Monday and that happened on Thursday. Monday and Thursday. Miles jogged was 5. That only happened on Saturday. So the way they've got this set up, they have input as miles jogged and day of the week is the output. Is this a function? No. Because we could make it nice and specific. 3 miles, which was the input, right? 3 miles has 2 different days of the week, which was the output. But what we're saying here is that one input had multiple outputs. So if I say the input is 3, do you definitely know the output? No, because it could be Monday or Thursday. So the fact that there's not just one output that we're leading to means the input doesn't directly lead to one output, which means it's not a function. Now this is one of those that if we switched them around and we made day of the week the input and we made miles jogged the output, then it would work. Because if I just said to you, Monday, if I said Monday is the input, do you definitely know the output? Yeah, you know the output is 3, and that's the only one. It doesn't matter at that case that Thursday also goes to 3. The idea is that every input only has one output. So if I say Monday, you know the output because there's only one. If I say Tuesday, you know the output because there's only one. So if I were to switch these around, it would be a function. But the way they've got it labeled, it's not. All right, you guys need to grab page 63 right now. Grab page 63. And what I want you to do is I want you to pause the video. Promise me you'll pause it and try it because your math thinking is so much better if you actually try. Pause the video, and it says Jason spent the week fishing at the Springville Fish Hatchery. The table below shows the number of fish Jason caught while there. So you're going to pause and you're going to turn this table into a graph. And then see if you can come up with, maybe you can't come up with all 3 ways, but maybe you can come up with at least 1 or 2 on how you know that this is a function. Pause me and give that a try. Okay, here's my graph. So it said label each axis, and I really had to label with words and numbers so that I could even see what this graph was about. Notice that I did make everything go by ones, but that doesn't mean I have to label every one. I labeled the even ones, and then you can tell what's going on. It gets a little squishy to try and label every single one. So is it a function? Yeah. Every hour has exactly 1 number of fish caught. If I say to you 2 hours, do you know exactly how many fish Jason caught? Yeah, because the only thing 2 leads to, even though some people say, oh, Ms. McGowan, look, it's here twice, but both times 2 hours was 6. So every input leads to exactly 1 output. If I say 4 hours, 12 fish. You know, because every input leads to exactly 1 output. Also, this graph passes the vertical line test. I can draw vertical lines anywhere in this graph and I will only hit 1 point. And this is a good reason for a function, which we'll learn more about moving forward. This graph is a straight line. It's actually even a proportional line, if you remember that from 7th grade, a straight line that passes through the origin. And every straight line is also a function. Again, we'll talk more about that moving forward. Just to get the language behind this, let's fill in the blanks here. The number of fish caught. Notice we started with the output. The number of fish caught is a function of the number of hours Jason has spent fishing. The number of fish caught is a function of the number of hours Jason spent fishing. That's how we word that. Okay, let's try this one more time. Sean also spent the week fishing. The table below shows the number of fish Sean caught. So again, you have a table, make a graph, and then answer these questions. Once again, pause me and make your graph. All right, check it out. Here's your graph. And it says, write at least 2 ways you know this relationship is not a function. This input of 3 hours leads to 2 different amounts of fish caught. So if I say to you 3 hours, do you definitely know the output? No, because one time it was 1 fish and one time it was 8 fish. So this does not represent a function. Also, the graph fails the vertical line test. Warning here, please do not write that this is not a function because it's not a straight line, okay? You can absolutely use the graph as a straight line to support that it is a function, but you can't use not a straight line to say it's not a function because as you'll see, there are lots of things that are not straight lines, but that are still functions. You actually saw them on is it a function or not. Remember the ones that curved, but they kept moving forward? Doesn't matter that it wasn't a straight line, it was still every x had exactly 1 y. So in this case, every input does not have 1 output. So the number of fish caught is not a function of the number of hours Sean spent fishing. So you now have those 2 pages of notes filled out. If you have any questions as you work on your quiz today, of course, ask your math teacher.